So with that, it's my pleasure to introduce our very last speaker. As you may know, our brains discard the vast majority of information that they receive before it gets to your conscious brain. But we can train our brains to recognize this, to recognize patterns. And then once you do that, they're extremely good. Their brains are extremely good at seeing these patterns. So this session will help us see some new patterns. Llewellyn Falco is an independent agile coach who discovered strong style pair programming and is the creator of the open source testing tool approval tests. Welcome, Llewellyn.
Thank you. Hello, everyone. Thank you for staying around for the very last talk. One of the things that I love about craft is we get to talk about the small details of the craft, right? And it's not always a good place to do that, but this is an excellent place to do that. And I love programming and I love the details of programming. And I want to talk today about a pattern that I've noticed has been really, really helpful for me. And it's a pattern I call many of one. Now, I don't know if that's like the official name, but I have searched all around and I can't find an official name for this pattern. So if someone knows one, let me know. The other thing is there's going to be a lot of exercises and code in here and extra resources. And if you grab that QR code, or here, I'll make it a little bit bigger for you, or you can put the URL in there, and hopefully someone will put that in the chat. That will have links to all the stuff. Now, I will put this at the end of the talk as well, as I've noticed some people prefer to get their stuff up front and other people want to wait to decide if it's worth it. So what is the many of one pattern? Really basically, I am saying that while you can make a single variable and say, team is Scully, you can, let's do that. So you can also say, I can make an array with a single value. And what I want to show you is there is a lot of places where this is a much, much more powerful, a much more greater concept, a better step to take. So let's look into this. There are two reasons that I like this pattern. You're going to see both of them. We're going to start with refactoring. Refactoring is really important to me. And when you are refactoring, it really helps to be able to take a big problem and break it into lots of small steps. My mom used to say, inch by inch a cinch, yard by yard makes it hard. If I can take a problem and put it into lots of little problems, I'm going to go through each of those problems much quicker and the entire problem much quicker. But another thing that's really important to me is backwards compatibility of my APIs. So I maintain some open source projects. And when you are maintaining things that go outside your company, or sometimes even if your company just has very strong walls, being backwards compatible on an API is really helpful. And this pattern also allows for backwards compatibility that's really, really powerful. So I'm going to talk about both of these things because they both apply to this one pattern. And before we get into any of that, let's just talk a little bit about why we even talk about patterns. Right? And this is like just a little bit meta, but our brains, the thing our brains do really, really well, that they're so good at, is discarding information. We take in millions of inputs a minute, but we only process somewhere in the neighborhood of like 40. The vast majority of stuff that comes into us gets discarded. That's what our brains are good at. And if you want to open up something to not be discarded, if you want to tell your brain, I actually want to pay attention to it, the way you do that is by giving it a pattern. Our brains love patterns, and it says, oh, that's something to pay attention to. So hopefully, by the end of this talk, you will become comfortable and familiar enough with this pattern that over the next year, you will see lots of opportunities to use it. Now, that doesn't mean you will use it, When those opportunities come up, you're going to say, yeah, this is a good thing to use now, or this is not such a good thing to use now. The thing that I'm concerned about, the thing that I want this talk to achieve, is that you have that conversation, that you decide this is an opportunity to take advantage of or not, instead of it just going by, being discarded, and you never realize it was even possible. So, many of one. There's a saying that programmers only know three numbers: 0, 1, and many. And so let's take a look at those numbers. Like here I have, I actually have two things here. It's a little hard to see. So the first thing I have is a method that takes 0 parameters. I also have no variables. 0 is a tricky concept. Here, I have a method that takes 1 parameter. And I have a variable that has 1 value. And finally, I have a variable that takes many values. I have an array, or a list, or a collection, or enumeration. But I have many things. The concept of many of one is, let me create a container that only holds one thing. Let me create an array that only holds 1 value, a list that only holds 1 value. And the reason, one of the reasons you want to do this is because it's a number between 1 and 2. We don't normally think that there are numbers between 1 or 2. Definitely not integer numbers between 1 or 2. Right? So we have 1, here's Sully, and we have 2, Sully and Mike. But when you realize the many of one pattern, you can realize there is a number between this. There is an array of Sully. This is what we're going to look at. So we're going to do 4 exercises here in code, each of them sort of looking at this pattern, the same pattern, but applied in a very different context. And the first context that I want to look at is refactoring. So a couple quick things on refactoring. First, small steps. One of the things that goes wrong the most in refactoring is people try to do too much at once. I am a huge fan of lots of small steps. And in fact, I use something called Arlo commit notation, links in the references, but you will see me using that in committing on all of these little steps. If you don't, this is where it goes wrong. This is where things go wrong all the time. People try to do too much. There's so many times where people are like, I don't have 2 weeks to refactor. Refactoring shouldn't take you 2 weeks. Refactoring should take you 2 minutes. And then you repeat it for 2 weeks to get to where you finally want to go. But every step along the way, you are making progress. So we are going to look. Ooh, sorry. Yes, okay. I missed one slide, but I do want to talk about it, which is, oh no, I don't. I did not miss one, my mistake. All right, let's take a look at variable. So the idea here is that I have a variable and I want to put it in a container and then call it. Doesn't seem very big, but let's take a look at how this plays out in progress. So we're doing stuff here in Java. I have some code. I can run this code. Yay, test, they pass. And I have this method, print primes. So I'm going to go into that. And indeed, just as we said, I have this number. It's a single number. I'm going to change it. This is going to be less happy with me here, so let's explicitly do that. So now I have this array, and again, to do the array, I need to pull it out. If I run this, it should pass, and we're going to do many of one as our commit message. So now that I've done this, I can loop through these numbers. Right? So I'm going to take that number 1, number 1 is, well, it's still good enough. All right, and we're going to go through all of them. And there's only one of them, so I can just put that in there. I always can put a loop around something that only does it one time. Ooh, I forgot my lowercase r. The next thing is this, the first value of number 1 is going to be I. So I can replace that with this. And now that I've created this space, I can take 2 and I can move it into there. Many of 2. And then I can do the same thing with 3, 5, 7, 11, and 13. So I think most people, when they saw that first piece of code, they see the duplication and they can see a way to pull it out. But they would do it as one step. I am doing this in 5 steps. And again, I see value in breaking bigger problems into smaller problems. So next, let's take a look at a slightly different but very similar example. Instead of a variable, we're going to look at the loop. Now, we used a loop in the last one as well, but we started with the variable. Now I'm going to start with the loop. So here we see a very, very similar block of code, but I'm printing numbers up to 7. So I'm going to start by introducing a loop. I'm going to loop over something one time. Again, I can always loop over something one time. And I'm going to take this first part and move it into the loop. So again, many of 1. And now, oh, you know what? This would be nicer if it started at 1 and went to 1. So I'm still doing something one time. I'm just doing it in a slightly nicer way. 1 index. And now instead of saying number 1, I can say I. And now this is not needed at all. I can just remove that local variable. That's actually an automated refactoring, so I can use lowercase. Dead code. And now I want to go up to 7. Many of 7. And so you can see these are very, very similar, but if this went up to 700, it would have taken me the same amount of time. Where if I had printed out 700 primes, you would have seen me typing for a while. And again, if I look at this, we're looking at 1, 2, 3, 4 commits to do that refactoring. So next, let's take a look at using the same concept of many of 1 with variable arguments. And this is a thing I usually use to maintain backwards compatibility in my API while extending the features. And for this is the quote that I was thinking of earlier, which is Kent Beck saying, make the change easy and then make the easy change. Warning, the first part might be hard. I bring this up because I want you to pay attention to what I do to refactor this versus what I do to actually add the feature. They're going to be very different amounts of work. So basic idea of a variable parameter array is instead of taking a single int, we take an array of ints. And compiler puts that together for us. So let's take a look at our situation here. So here, I have the ability to say merge. I give it a number and it makes it look like this. And what I want to do is I want to add the function where I can just pass in as many numbers as I want, and it puts them all together like this. I'm using multi-line strings because I'm in Java 15. So let's go into here. And we already said, like, the thing we're going to do here is make this many, which means this needs to use the first one. The nice thing is I did not change the test, meaning that API did not change, right? Open many of one. It still only works for the first number that's passed in, right? You could pass in more, but it's not going to work. The next thing is I'm going to pull this out as a variable. And let's get that as a variable by itself. Extract variable. And then I'm going to also notice that I can separate this. Split into here. And it might be nice to actually make sure that this works regardless of what happens. And now I can add my loop. And again, since I'm just reassigning the entire thing, I can move this inside. But now I think it might be a good idea to open up this ability. I want to show, if we run this, it fails. This feature doesn't work right now. It's been a pure refactoring. Even though I'm passing in all these numbers, I'm not getting 2, 3, 4, or 5. However, let's implement the feature. So I'm going to put a plus equals here, and I'm going to change this to an I. Capital F, feature, much more dangerous than anything I've done. Added multiple numbers. So we talked about make the change and then make the easy change. Ooh, not what I meant to do. Let me try that differently. This change, it's one line. It's like 3 characters. That's how much it took for me to add the feature. That's make the easy change. So again, we have this thing. It takes a number. You know, it's worth mentioning that we are taking 1. We could have took 0 as well and just put the container right up front. But either way, we move to a variable args, and everything is maintained. Everything stays the same. No breaking of an API whatsoever. So now we're going to get a little more complex on this. So in this exercise, I have the ability to format a number. And when I format it, it comes back as number 1. What I want to be able to do, I can't do it right now, but I want to be able to say, I want to change what the prefix is. And I want to be able to say what the suffix is. And you know what? Eventually, I want to be able to say what both are. But let's start with the refactoring. So no change in behavior, but I need to add the ability to change it. I want to add this many of 1. Now, there's a couple ways you can do this. If I was in, any other language, Python, C++, C#, Ruby, PHP, basically anything. What I would do here is I would say format options, options equals null. I cannot do that because default parameters do not exist in Java. So what I'm going to do is actually sort of derive this. So what I'm going to do instead is I'm going to say format options, options equals, and we'd read declared here, so new format options. I think it's worth saying what this class is. So let's show you the whole class. It starts here and ends here. It's nothing. It's a completely empty container. And now that I've done this, I can extract, oh, sorry, let's run that. See that that still works. Added dead code. Now I can extract this as a method, and I'm going to call that format as well. But this one, I want to pass in options. No, sorry, undo that. Let me try that one more time. Oh, I have to do it here. Oh, IntelliJ, you let me down. Ooh, ah, super let me down. Let's try that again. And we're going to make that public. All right, let's run that. Should work exactly the same. This is the Java version of adding an optional variable. So now that we have this, I want to use it. And specifically, I got this prefix thing that I need. So what I'm going to do is copy that and say options.get prefix. Now I need to create that, and I need to return it. Well, let's hope my memory holds well enough to do this. I think that's correct. We'll find out though. I have tests. Yay! This is really just an extract method. It's just not nicely automated. And then that I have that, I can extract that to a field. How about prefix? And in fact, I'm going to do the very un-Java-like thing of changing this to public. There are much better patterns to do this, and I have links to code implementing that better pattern in the resources, but it's much more complicated, not appropriate for this talk. Extract field. And in fact, it'd be nice if that was just assigned there. I like that better. All right. So now that I have this, I basically get my feature for free. Oh, maybe I don't. I don't, because I cannot spell. Let's rename that to prefix. And this, ooh, actual. Let's try that again. There we go. So this is actually feature. That rename gives me ability to define the feature or prefix. Technically, it was the turning public. So now let's handle suffix. So again, we're going to do some refactoring, right? So let's go to our code, and the suffix is here. It's a little bit hidden. So let's expose it. And then I'm going to do basically the same thing you saw before, get suffix. return it there. And then I'm going to take this, and I'm going to turn it into a field. Spell it correctly this time. And then I'm going to move this field to the declaration. And finally, let's go to our code. This is the code. This is the new feature that I want to implement. You'll notice it does not compile. I am going to, nope, I'm not going to do that. I'm going to make it public. And that is my new feature. But what about that last feature I wanted? I wanted to be able to handle both of them. Well, that one I get for free. Lowercase t because it's test only. Test feature 3. It's actually feature 4. Should fix that. All right. So let's go back and take a look at this. The first thing I want to talk about is a lot of times when I show people this, they're like, wait a second, where's the mini of 1? All this time you were showing me arrays. Right? Why am I not passing in this array of the list start and the list end? Well, I'm passing in now what would be more considered a dictionary. A dictionary or a hash map. Really, that's what objects are. I have multiple things, in this case a prefix and a suffix, and I'm just putting them in a container. I don't change the API at all. And what's nice is because I don't change the API, if this cascades down, if this call calls another call that calls another call, I can just fix it. I can just add to it. So we had this format. We moved it to take the optional options. Now, it's worth saying what happens if we already had the method that had the prefix. Here we're going from 0 to many of 1. What if we had 1 and we want to move it to many of 1? Well, that's also okay, but you need to put an extra step. So we have format that is already taking 1 option. Then we have to put 2 methods in place. One that takes the optional options, and the other one that just calls the method underneath and sets up options as it wants to be. And this ability for these methods to compose like this is really powerful. You're going to want your options to be immutable. But again, not a hard problem to solve. All right, I got one last thing for you before we call it a day, which is testing. So in this situation, I'm trying to do FizzBuzz. I haven't gotten very far. I'm just on the first part. But I have gotten number 1 working, and now I need to go and handle number 2, and then 3, and then 4, and all the way up to 100. So that should be 100 tests. Well, I can use the same many of 1 concept here. So let's take this and put it into a 1. And here, pull it out. This is all test code, but many of 1. And then approvals actually has a very nice way of handling things that are many. So we're going to say verify all. We're going to give it an empty header. And instead of the result, we're going to say, let's verify all the number. And I really want this transformation to occur. So what I'm going to do here is I'm going to say n goes to, and I'm going to go straight to using the number. Actually, let's leave that in, but let's run that test and see that it still works. Yep. Verify all. And then finally, this is now dead code, and my editor is even telling me I can get rid of that. And then this is really, I want like some numbers here. So 1 is the same as saying, give me the range from 1 to 1. Test range. And now let's take a look at 100. Now I haven't implemented FizzBuzz, so this is not going to work. But notice here, I'm getting all 100 numbers. It's a little hard to see what's actually happening. So let's actually modify this a little bit to give me a little more information. And instead, let's say n goes to this. And there we are, 100 tests, showing, by the way, that most of these numbers are not correctly implemented, but testing 100 different cases. Now, as I do this in real life in TDD, I usually would actually just increment the range as I'm going, right? Take steps that feel comfortable. But look at how easily I just wrote 100 test scenarios, because I took something that was a 1 and converted it to a mini of 1. And this is sort of the whole, oh, right. So I could do that, by the way, as a range, but I also could do it as just a collection of numbers that I thought were interesting. And this is the whole moral of today, which is first make the space and then fill the space. Way too often I see people trying to do both of these things at the same time. Make the space first, then fill the space. As I said, all this stuff, including all the commits we did today, will be on a branch published under Craft. You can grab all the resources here. Thank you for spending the half hour with me. That is all I got. Thank you very much.
Thank you. It was very enjoyable diving into just the tiniest details of refactoring. That was pretty cool. Thank you for that. Let's see if we get many questions.
Should I continue to share the screen, or should I stop?
It's fine. You can leave the screen share up.
Okay.
See if 1 moment. Yeah. So I'm just keeping half an eye on the Q&A tab. There is some delay between you talking and actually making its way to the stream. So let's give it some time. Yeah, I guess in the meanwhile, what are some others? I took half a look at that link that you sent over. There are some, and I shared that in the chat as well, by the way, for easy clicking. What are some? Oh, hang on. Actually, there's a question, so I'm going to stop talking and just read that.
All right.
Balaj is asking, in the second example, why not use overloading to introduce a new function having a collection argument, leaving the original function safer?
Right. So there's 2 options for that. So if we go and take a look at that, can they still see my screen?
Not at the moment, but I think we will be able to put up some more.
I will talk it out then. So if you have var args, var args in general means 0 to many. But if you want it to be 1 to many, I absolutely suggest using that technique. And in fact, we do use that technique in production, right? Where when we want to do that, we even have a, let's see if I can pull it up right here. Array utils dot combine. Yeah. So we have a function here. We'll take this one. Oh no, I don't want that one. Try that again.
And your screen share is not visible, by the way. Just heads up.
So what this does is it just takes a single instance of a value, like an int, and an array of the ints, and it combines them together to give you an array of ints, right? And usually if you're going to use that pattern, that's the first thing you will do is just say, hey, combine these and pass it on. Or don't even pass it on. If 0 is not a valid amount to put into a var args, use this pattern. And again, it works for 1, but it works for 2, it works for 3, however many you want to require. So you can say 4 or more, pass in 4 individuals. And this is a concept called pokiyoki in Japanese. And it means idiot proofing. It means you can't do the wrong thing. Because if you can't take 0, rather than throwing a runtime exception that says, I can't take 0, instead make it a compile time exception, right? It's just a much better way of doing it. And absolutely, I recommend doing that if you have a public facing API.
Yeah, fairly early and all that. Yeah. Okay, let's see if any other questions come in. In the meanwhile, the one thing I was curious about is, as you were going through these exercises, like you made extremely small commits with extremely specific messages, and like,
yes,
that's just for the exercise, right? Like, surely
no,
I'm not doing commits completely wrong.
Absolutely not. I love lots of small commits for multiple reasons. One is it makes pull requests so much easier to pay attention to, right? So if you're looking here at the things that have changed, right? All the lowercase letters I can ignore. Refactoring is a particularly hard thing to get a pull request approved on, because you can do even just a rename can change, 500 files, right? Often if you refactor code, every single line of your code can be different, right? If you just reformat code, every single line of your code can be different. So I like having these small commits so people are like, oh, that's just a format, I can ignore it. And so rather than going through the bunched up, here's everything that's different, they sort of replay the steps that I played when I created the code. And that turns out to be very, very nice for pull requests. It's also very, very nice for debugging, right? So I just did 32 commits in this last doc. Let's say I messed up. This code goes to production and something's broken, right? It happens. If I do git bisect, it's not going to tell me something in the last half hour went wrong. It's going to tell me something in this 15 seconds went wrong. And that is so much easier to fix. And I've had very complicated situations that have shown up that I've been really, really grateful to have these small commits, because it's like, oh, floating point math does weird stuff that I didn't think about when I thought I was doing a safe refactoring, right? Or not even a safe refactoring, but I thought I was doing a refactoring. So yeah, I like these little commits for debugging. And then I also like these little commits for when I have to report. So if I was to go through here and say, oh, what did I do that's actually meaningful in the last half hour? I just skip the lowercase letters and the R's. And I'm like, oh, we allowed for a suffix. We allowed for a prefix. We allowed for multiple numbers. That's it. That's the only useful things. Like, those are the things I need to put into my change log.
Mm-hmm.
Right. So I really like these small commits quite a lot. And then there's one fourth thing. This one is a little tricky, but sometimes I'm working at a company, lots of employees, lots of teams. They're all working on the same code base. Hundreds of programmers, typing, committing stuff. You know my refactoring is going to cause a merge conflict. If I'm committing every 15 seconds, I am not the one who has a merge conflict. The saying that I think of is, be the bird, not the statue.
Right.
And if for some chance I happen to hit the 15 seconds where I do hit a merge conflict, I don't fix the merge conflict. I revert and I do it again. It is easier for me to redo 15 seconds than to understand what happened.
Fair enough. Yeah, those are some pretty good points. Yeah.
There's one other thing. Now, this is not exactly the same as the small commits, But some of the refactorings I did here use the lowercase r, and then some of them use an uppercase r. So just to talk about the difference of those two, it's saying the uppercase r's are more risky, right? Now, it's an uppercase r because all of this was supported by test. But if I was to ever do a refactoring that was manual and not supported by tests, I would include 2 exclamation marks on there too. So it'd be R exclamation mark, like it's shouting at you, hey, this is more dangerous. Now, in some places, it can be very hard to get things to production. And in those places, I will try to stay on a line that's all lowercase r's. And I will do that because I can say, listen, every single step here is provably safe. Let's release this to production. And I can do that without having to have a meeting about can we release this to production. And that meeting is often so emotionally painful that I will do an extraordinary amount to avoid it. And so that's like yet another advantage. It's not exactly the small commits, but it's a combination of the small commits plus this denoting risk in the commits. And then, not as valuable to me, but valuable for the rest of the people watching, if they wanted to replay this themselves, they now have like a 15-second breakdown of what I did. I keep saying 15 seconds, but it's 32 commits and a half-hour talk. It's got to be 1 a minute. My average is wrong there.
Yeah. I mean, you didn't spend all 30 minutes coding, so it's like, eh.
That's true.
Yeah, awesome stuff. Well, thank you again for being here and for taking us on this journey. We prepared a little gift for you that maybe we can show on the screen, and then we'll work on getting it to you in the real physical world. There we go.
Oh, beautiful. Thank you.
Thank you for being here and being our final presenter on this stage. It was great stuff.
This recording will be published, right?
As long as you consent to publishing it, it will be, yes.
I consent. I will add a link to it in the resources too once I get that link.
Actually, let me correct myself. I don't know if it would be published, like, publicly.
Oh, publicly.
But okay. Probably for
if it's published publicly.
I'm unsure about that.
If not,
make sure to check
I will keep it.
Yeah.
Thank you.
Cool. Cool stuff. Thank you.